this is your Math 159 class. Okay, online you can see at the beginning it describes how this class is set up. Okay, then you can see the syllabus. You need to read one by one, line by line. Okay, make sure you read it. All the class schedule is there. When we are going to have tests and when the homework is due. Also, after that, and you can see there is particular thing is the class notes for this class. First one is the blank one. So you will see the blank one like this. Then you can print it out. Then follow through as you are in the class. So we are going to do everything on the whiteboard so you can follow along with your notes, right? Also, you have a class notes with all the keys, filling all the blanks for you. It's just like your textbook. You can print that out as well and use that as a reference to follow along with the class. Okay, but I recommended you to use the blank one, printed out the blank one, so when you listen at the same time, you can fill in the blank, and just like you are in the class. So follow along, so you write it down, you can remember better. Okay, so this class, we emphasize on the decimals, but not that much on fractions. And somehow, this class assume you have the fractions training and decimal training in your middle school or high school already. We just do the brief review for the fractions, and we describe the decimal more in this class for the purpose of stats. Okay, so if you have a problem with the fractions, either you take, adult education classes to catch up, or you use the LTCC online tutoring center through the library, Cranium, Cafe, then you can get help there as well, okay? Or you can call me. But if you totally have no idea about fractions, that means you are not ready for this class. You need to do something, okay? And talk to tutors or talk to me. Then we see how you can catch up, because we don't even do the detailed reviews for the fractions. We just do the quick review. Assume you already knew something about fractions, okay? Otherwise, we will start everything from the beginning to explain to you. We explain to all the terms we use in this class, so you should be able to do okay. Okay, so at the beginning, you are on the page 1. Okay, on your notes, it describes all the sections we are going to cover. And you have textbook reference, you can go online to see it, but the sequence is a little bit different from the textbook. Textbook, it's just like stats, quantitative reasoning, so all the data are flying everywhere, okay? So you have to make sense of it, but we try to let you learn sequentially, step by step, explain to you where things are from and where we are going, right? So if you follow through the course, you should be okay and do your homework and practice. Okay, so We are on your notes, page 2. Start from page 2, section 1.1. We started from decimals. Then you need to run on the decimals for this class. So it talk about a lot of rounding and scientific notation. Okay? So when we run, we have to run to certain place, certain positions. So what we do is each position we have name, right? So we will explain to you how we recognize them. So like if you have a number, okay, like this, 4, 2, 8, 6. How would you say it? Okay, what kind of positions it is? So for numbers, every 3 of them we have a comma, right? So those are ones, right? Next position would be what? On your paper you have what? Tens and hundreds, right? Ones, tens, hundreds, and thousands, right? Then 10,000s and 100,000s. Then after that, you have what? Million would be millions, 10 millions, 100 millions. After that, you have what? Billions, 10 billions, 100 billions, right? Then we have what? Trillion, 10 trillions, 100 trillions. So like this one, what would we say it? That's 1,000 position, so 4,286, right? So that's a whole number place value chart we use. Then for decimals, like this one, we don't say 4,000 and, right? 286. We just say 4,286. And it's reserved formally, okay? Reserved for the decimal point, okay? So that will be your ones, right? Then before the decimal points, then you have ones, tens, then that's your hundreds, right? Then after decimals, just like your 23.8497. So that's a decimal point, that's ones, tens. For each one behind the decimal point, first position is what? Like 8 at the first position will be what? We call it tenths, right? Next one will be what? Hundredths, right? Next one, the 9th position is what? Would be your thousandth. Then after this, it would be what? 10,000ths, right? We don't use comma after the decimal point, only before the decimal point, right? The next one, so same thing as here, 1,000, 10,000, 100,000. So that's the decimal position. That would be what? 100,000th position. Okay? So if we do the rounding, let's see. We know the position, the name of the position, right? Then if we write the name for this position, for the decimal, we will say what? 23 dot, decimal point, you say 23 and, right? Then how many of them? Then you say the decimal points. To say it is, yeah, not that straightforward for the decimal points, but for this class, we don't emphasize how to say it, okay? So it's not that straightforward. So then we have 4 decimal positions right now. Then when we round it, look at your page, we write it out for you, note, right? For the rounding decimal. When you round, everything to the right of given place value becomes 0. Because once you round it, the remaining part, you don't need it anymore. And the digit in the given place value either stays the same or round up 1. Trailing 0 after the decimal point usually would be dropped. However, it is different in statistics. In statistics, you would keep all the digits to the rounding decimal place to emphasize the accuracy. Let's talk about what we mean by that, okay? Also, when asked to do arithmetic and present your answer rounded to a fixed number of decimal place, only round after performing the arithmetic. It means when you do all the calculation, you have 2.3 times 5.7, 2, 4. Then we say, oh, round it to second decimal place. You don't round it before, you don't round it now. You round it when you finish. Okay? So let's do the rounding first. Then we see what we are talking about here. Then that's a review for the whole number. How do we round it? Okay, so that's 4,200 some numbers. So you say round it to the nearest 100. So first you locate where is 100. Ones, tens, 100, right? That means you want the number all the way to this position. The rest of them, you don't really care. Okay, so then how do you round it? If you round it to the next number, for instance, why do we have to round? Okay, so if, say, you have $27. Okay, if you owe me $27, then you only have $10 a bill. So, what do you think? Should you give me $30 or $20? You'll have only $10 bill, right? If you owe me $27, what do you think? Which one is closer? 30, right? Be more reasonable. So what do? You compare this one, it's more over 5, so you round up. So we even round down or round up. Okay, if you owe me $22, you only have $10 bill, what do you think? It would be $20, it's closer. Okay, if we do estimate. Rounding is like estimate. So you look at the number behind it. So like we say, you either drop it or round up. Okay? So like this one, we want to round it to the 100th position. So you look at the number behind it. If it's bigger than 5, then you round up. So you drop those, you round up, increment by 1. So your number will be what? 4300. The remaining become a 0, right? So that's how you round. Then for this number, next one, we say round the 23.8497, round it to the nearest 10th. So you locate where is the 10th? First position. Then you want to keep the accuracy to that position. Then the remaining, we don't want to use anymore. Okay? That means rounding. But you have to decide, you have to round up or round down. If the next position is less than 5, you round down. So get rid of. So the answer will be what? 23.8, right? This is the original number. So if you wanted to round it to the second one, round it to the nearest penny. Penny will be this position. That means you want to keep all the way to the penny. The remaining, you don't want it, but you have to decide you want to round up or round down. Because it's bigger than 5, so you need to round up, increment by 1, right? Okay, then next one. So if we want to round it to nearest unit, unit is what? 1 position, right? So we don't want the remaining decimals for it. So you don't need those numbers. You want to be right here. Then you want to round up or round down? Above 5, so your answer should be what? Oops, round up, right? Then we don't want the rest of them all the way to the unit. And next one, round it to the nearest 10. So your 10 position is what? Here, right? So you look at it. So you don't want the rest of them, but you cannot just say 2, right? Because it's whole number part. Decimal, you can just drop it. You have $23. It's the same thing as you have $23, 0 penny, right? 0 dime. But for 23, if you round down, you just say 2. You cannot do that. You have to do all the way to what? To this position accuracy, but the rest of them you want to drop it, but because it's whole number, you want to keep the number 23 close to 20. Okay, you cannot say just like a decimal 00, you can ignore, right? Whole number 2, it's different from 20, it's different from 200. So it's a little bit different. You need to keep all the way to the decimal spot. Okay, next one, 23.8497. We want to round it to nearest thousandth. Okay, so which one is the thousandth? Which number? This one is what? Tenth, hundred thousandths is this guy. So you want to keep all the number up to this point. The remaining you don't want. But you have to decide it's up, round up, or round down. According to this, above 5, you have to round up. Round up 9 become what? 0. So increment here become what? 5. So your number will be what? 23.850. You wanted the 0 there for the accuracy because it says what? Rounded to the thousandth. So you have to keep tens, hundreds, thousands to show the accuracy. Right? Okay. Then we write down the when we do the application on your bottom of the page 2, when we do the application, it says rounding is used in most area of statistics, since the calculator or computer will produce numerical answers with far more digits, many digits, right, than are useful. If you are not told how many decimal places to round to, then you often want to think about the smallest number of decimals to keep so that no important information is lost. That's the purpose of rounding. Okay? Then look your page 3. Next page. Next one. And about rounding. So suppose you have this, right? Suppose that you found out that the probability that a random select person with whom has misused prescription opiates will transition to heroin is what? 0.049987113. Round this number to the 4 decimal places. So in stats class, you have a bunch of words. You have to understand the meaning of the words to make a decision. Right? Okay? So it says, suppose that you found out that probability, and you have no idea what is probability yet, right? Okay, but look at the question. It says, the probability that a randomly selected person with who has misused the prescription, okay? Then transition to heroin is such chance. So this one is a probability. So it says round this number to the 4 decimal place. You don't really understand what they are talking about, but you know the question. What was the question? Round this number to what? 4th place, right? 4 decimal place. Actually, probability means what? It's the possibility out of the whole possible scenario. Means what's the chance? It happens from the people who misuse the prescription opioids and change to heroin, right? So, but the question, you can do it. It says what? Round this number to 4th place. Of course, you can do it. And how do we do it? So, 4th one, then you look at the 5th one to decide. You don't want anything after it. So this one is bigger than 5. You need to what? Round up. So this one, add 1 becomes 0, add 1 becomes 0, this. Right? So the answer should be 500. That means accuracy all the way to the 4th decimal place. That's how you do the rounding. So, but for the class, maybe you answer 0.5, 0.05, then it's fine. But for the purpose of accuracy, you should answer what? 0.0500. Okay? That's about the decimals and roundings. So for section 1.1, we are going to talk about rounding, which we just did. Also, we are going to talk about something called scientific notation. So this section, we talk about 2 things. One is decimal roundings, we just did, right? Another thing is scientific notation. Before we can talk about scientific notation, we need to talk about something called exponents and roots. All right, see if you still remember. So, what are exponents? So, exponents, sometimes we call it power, right? Or we call it exponent. So they are shorthand writing for the repeated multiplication. Let's see, what do we mean by that? Okay, so if you look at some example, 3 squared. So 3 is what? On the bottom is your base, right? The top one is what? Your exponents. Then sometimes we call it power. So what does that really mean? And when we write it, if you call me, you say, oh, I have this problem, 3232. I wouldn't know what you are talking about, right? So the actual meaning means what? A shorthand writing for repeated multiplication means what? 3 times itself, how many times? 3 times 3. Actually, it's 9, right? So the bottom one, we call it what? Base, or the root. The top one, we call it exponent, or the power. Actually meaning is repeated multiplication. Multiply itself twice. Then when you describe it, how would you say it? You would say 3 to the how many power? Second power, right? 3 to the second power. Or you can say 3 squared. Then we know exactly what you are talking about, right? If you have 2, 3 like this, 2 is the base or root, and 3 is the exponent or power. How would you say it? You would say what? 2 to the how many power? Third power. That's where we are, right? Or we say 2 cubed. Okay? So, when you use calculator for the powers, right? For those things, just about every calculator, computer, or smartphone, you look at your phone, can take powers of a number. We just need to remember the symbol. Okay, so how do you find it? Say 3 to the second power, it gives you an answer for 9, or 2 to the third power means what? 2 times itself. How many times? 3 times. It should give you an answer 8. But how do you put this style? Right? Some calculator will have this base and have this one little things here like this, so you can put it there. But some of them don't have it, but they always have this symbol. Okay? Then it's this symbol. Okay? And for the calculators, you will always see that symbol, or on your keyboard, and Shift 6 on the keyboard. Means what? To the power of. This one means power of. So if you do the power of 3, that means what? It means this one, it will give you the 8. Okay? So we also need to remember to use parentheses if we need to force other arithmetic to come before the explanation. Okay? So let's see. If you have this one, if we ask you to do this, okay, so if we ask you to do 0.2 to the 4th power, right? It means what? 0.2 times itself how many times? Repeated multiplication, right? 4 times, that would be what? Do you remember how to do your multiplication for the decimals? 2 times 2, 4, 4 times 2, 8, 8 times 2 is 16. But how many decimal points do you need? 1, here 1, 2, 3, 4. Total you need 4. So you have to count the 4, then that's your decimal place, right? What happened to the empty place? You put a 0 there. So that would be your answer. Then if you use calculator or computer, how do? You do 0.2, then you use this symbol, right? And to the 4th power. It will give you that answer. Then we need to use power 10. 10 to the 1 power, 10 times itself, what? Once, that's 10, right? 10 to the 2nd power would be what? Times twice, right? That would be 100. 10 to the 3rd power would be what? Times 3 times, that would be 1,000. So, did you see the pattern? 1 power, 1 0. 2 power, you have 2 0. 3 power, you have 3 0. Right? If 10 to the, say, 15 powers, so what do you expect the result? You have a 1 in front of it, then the remaining is 0. How many 0 you should expect? 15 of them. Right? That's when you do the power of 10. So, we are talking about powers, exponents, right? Then we want to do something called a root as well. Okay? Root is what? The bottom one, the base. Power is the top one, right? So root is opposite of the power position. So we are going to learn perfect square and the root. Okay, so what are roots? So take a look. So 2 to the 2nd power square, right? Is 4, and 3 to the square is what? 9. 4 square is what? Times twice, 16, right? So 2 is your base, is your root. Then this is the power, that's the result. Okay? Now, if we do the opposite, we ask you, what is, that's a square, right? What's the square root of 4? Square root of 4 means what? We are talking about a square root. A square root means what? Find the root of a square. Okay? So we want to find out who is the root. Take a square becomes this number. Who is the root? What's the square root of 4? That would be what? The root is what? It should be 2, right? The root make the square, if they take square, become the 4, right? Square root, root of square. So if you have square root of 9, who is the root? Square root is root of square. Who take the square become 9? So the root is what? The 3. So what is the square root of 16? That will be the root. That would be what? 4. Okay, that's the perfect square. You take a root, and square root, you find the root. Okay, if it's a good number, it's a perfect square. Then we need to use calculator to figure out how to find the root. If it's not perfect square, then what we are going to do? Okay, take a look at your page 4. Let's see how we are going to use calculator to find the answer. Okay, so if you have a square root of 0, you can see from your calculator, you should have this symbol, square root. Then you just punch in the number, use that symbol, then you should get it, right? If you have a problem using calculator, you better go to Math Center, LTCC Tutoring Center to figure out. And depend on your calculator, they can show you how. Okay? Or you call me. So, square root of 0, what number, which is the root, take a square will become 0. That's 0. Right? Then square root of 1 is what? Which number? Take a square is 1. That's 1. Because 1 square is what? 1. Right? Square root of 4 would be what? 2. Right? Because the root of square. And 2 take a square is 4. Square root of 9 is what? 3. Square root of 16 is what? 4. Right? Because 4 squared becomes 16. However, those are reasonable numbers because it's a perfect square. We call them reasonable number. We call them what? Rational. Rational means reasonable. Right? However, what happened to square root of 2, square root of 3, or square root of 5, 6, and 7, or 8? Right? What do you think? Anything take a square is 2? No. 0 square is 0, 1 square is 1, 2 square becomes 4. Right? So it's no good number. Take square is 2 or 3. Then how do we find the approximate number? Square root of 2 and 3, it should be, what do you think? It should be what? Between square root of 1 and square root of 4, right? And this number is not reasonable like this, just a perfect number. So you use the calculator, use the square root symbol, you can find out this would be 1.4142 or something. Then this one would be, you better practice this, right? See, you can find this number. In class, I can check for you. And here, you can call me. Then we can talk over the Zoom to see how would you make it, right? So, see, 2 and 3 is between 1 and 4. So square root will fall in between 1 and 2, right? You better figure out how do you get this number. What do you think? 5, 6, 7 is between 4 and 9, so it should fall into about here, right? If you get a number, it should fall in between 2 and 3. So you take a square root of 5, you should get a what? 2.2360 or something, right? Practice that. And how about this 6? You should get a what? 4494. And this one, 2.6457. Make sure you get those. Okay? Are we good? Okay, and those numbers can go forever, the decimal places. Okay, so it's not that straightforward for you to comprehend. It doesn't look like reasonable, right? So we call them what? Unreasonable number, which formally we call them irrational numbers. If they are not a good number with radical signs, they are irrational. Okay? Next one. Let's see some examples. Here says, suppose you pick 3 cards from a 52 card deck. Okay? So 52 card deck, you have what? Spade, heart, diamond, and club, right? Each one have what? 1, 2, 10, and J, Queen, King. total 13 cards, right? 1 is the ace. Okay, so each one you have 13 cards, 4 of them, 13 times 4, you should have 52 card deck. Okay, deck. Okay, so here says, suppose you pick 3 cards. You pick 3 cards from those with replacement. That means what? You pick one, you put it back. Then you pick another one, you put it back. You pick another one, you put it back. And okay, and wanted to find the probability, the chance it happens, right? The possible of the event. Event we call an event, we use a symbol A. That none of the 3 cards would be a 2 through 7 of hearts. Then the probability, this event, we pick the 3 cards out of those 52 cards without replacement. Okay, if you pick the 3 cards for this event, your chance for the probability, we use P. Okay, in this class, you learn a lot of symbols. Okay, so probability for this event is what? 0.846 to the cube. Right? You don't understand why, but for the moment, you're not figure out why it's this way. We just ask you what? Find the answer with the decimal point, okay? You don't know how the probability works yet. You will learn this later. And right now, we are learning what? The symbol. Okay, get familiar with all the symbols and relate to the English in meanings. That's what we are doing in this class to get you ready for the stats class. So probability for this event A, we put it this way. And what is event A as described? You pick the 3 cards from the 52 cards, okay, which only would be 2 to 7. You might have other JK, Queen and King, right? But we say from 2 to 7, you will have this answer. We want you to round this number to what? To the 2 decimal places. So what do? You use the calculator. So you do 0.8846 to the power of 3, right? Then you end up, you find out it will give you a bunch of decimals, more than you can handle, right? You times itself 3 times. But it says, oh, we're just concerned about 2 decimal places, right? So you want to up to 2. The remaining, you either drop or you round up. So what's the answer? The answer should be, you should give us answer is what? 0.69, okay? So you are learning what? About rounding. Got it? Okay, and practice use calculator. So for the second one, evaluate this. What do you think? How do you say it? 1.04 to the 5th power, right? What's the value of it? You multiply 5 times. So you use the calculator to the 5th power, right? You end up 1.21665 something. Then it says, rounded to 2 decimal places. We only want to have 2 decimal places. So you look at it, you don't want the rest of them, then you decide above 5, so your answer should be what? Round up with this. Are we good? Pretty straightforward, right? Just practice calculator for this part. And for this one, 0.5, 5.3 times 0.17. So to the power and rounded to the 2 decimal places. So power, you should do it first, right? So if you do on the calculator to the power 5.3 times 0.17, how does calculator will do? You will do the power first, then multiply. Then it's not right. Because if you do power first, 2.8 only to the power 5.3, not the whole thing. So when you enter the calculator, you need to do the power first. That means you need to do the parentheses. Means it's a group. You do that thing first. Okay? That's what it means. Then, if you do that first, you put a parenthesis, the calculator and computer will do this part first, then they do the power. That would be 2.52865 something. Then, you want you to have two decimal places to the 2. You don't want the remaining digit. Then this one is rounding up, so your answer should be 2.53. Okay? So, on the top for the square root, okay, we talk about you do the square root, right? If you have this symbol on your calculator, right? For all the square root. However, sometimes you should always have a square root. But if you don't see the square root, what should you do? Okay, look your page 4 on the top. We talk about using calculators for the square roots. Square roots come up often in statistics, especially when we are looking at the standard deviation. You don't know what's that, standard deviation. Just a new term for you. You will learn this later. Something standard about, and deviation means deviate from. Then you will learn that later. Okay, you just know, oh, you are going to learn standard deviation. Okay, then we need to be able to use a calculator to compute, okay, a square root of number. And there are 2 approaches that usually work. The first approach, like this, okay? Or you do square root of 10. Say, if we wanted to do the square root of 10, if you have your calculator, you find that, you just use that symbol. If it's not, okay, there are 2 approaches usually work. Okay, if there's one, you use that one. Then, for the computer, you can use this one. You put a number, square root of 10, you put a 10 there, you type in SQRT. Usually they understand you. Okay? And a second approach is another way. Okay? So they always have this symbol, right? And for the square root. So we say, if I use 10 to the second power, 10 to the second power, I will use what? 10 to the second power, that would be 100. But what happened, 10 square root of 10, you will do what? Means half. You will put 0.5 here. Okay? It means square root of 10, you do 10 and this square power symbol, then put a half there, 0.5. Take a power, then you will get the same answer as that. So for square root of 7, say, what do? You can do that way as well, okay? You can do it to the 7th, then power 0.5, and same thing as you use this symbol, you should get same answer. Okay, so for this section, you need to recognize the power symbol is this one on your calculator. Okay, if it's a square root, what do? You do the power symbol, then use 0.5. You will have it. If you look at your number 4 example, then you say square root of 42. Then you can use the simple square root. Then you put the 42 there. You get the answer. Okay? Another way is what? You do 42, then do the power symbol. You put a 0.5. Okay, half. Because you are taking the root, half of it. So you will have 6.4874 bunch decimals. It's rounded to the 2 decimal places. You keep up to here, don't want the remaining off, then you decide drop or round up. So for this one, it's drop. So your answer should be 6.48. Are we good? So what are we learning? We are learning decimal rounding, right? Also, we are going to learn scientific notations. Before we do that, we are doing what? Exponents and roots. And exponents, use this symbol to find the power. For the root, square root, you just put 0.5 there for the power position. Practice that, right? Good? Now let's do the scientific notations. Scientific notations, you can see we are using it for science purpose in science field, right? We'll use this. And let's see, when a calculator presents a number in scientific notation, we need to pay attention to what it means, right? Then the standard way of writing a number in scientific notation is not writing the number as a product of number greater than or equal 1 but less than 10, followed by a power of 10. You say, what the hell they are talking about? Okay, so let's visualize it. For the scientific notation means we have to write a number in such a way 10 base 10, because we have tens, hundreds, thousands. Everything is a base 10. Okay, we are going to write it in this fashion. Okay, something to the 10th power. Then we wanted to write 8 times 10 to the some power. You haven't learned algebra yet, okay? This class, we are going to skip all the algebra classes. 3 classes. You are going to use 1 class to replace 3 algebra classes to get you to the stats class. Okay, so A and R is a variable you will get familiar with pretty soon. Okay, so you are learning a lot of symbols and see what do they mean. And write in this fashion, then A is what? Between 1 and 10. Means what? 1, 2, 3, all the way to 9. No 2 digit, just 1 digit. And to the 10th power, R is something called integer. Okay, integer means whole number, 0, 1, 2, 3, 4, or negative number, -1, -2, all those numbers. Okay, That means if we write in this style, we call it scientific notation. You still don't know how it looks like. Then let's identify them first. Then you can have better feeling about it. If I write a 3.8 times 10 to the second power, scientific notation will use 10 as a base with the power. Okay, we are learning the rule and power and repeated multiplication. If we write this style, is the one we are talking about scientific notation? Look at that. The number in front of a power, 10's power, this number is that between 1 and 10, right? It's 1 to 9, yes. It's 10 to the some number power, yes. So if we write this style, it is a scientific notation. If we write a 42.1 times 10 to the 6th power, is this a scientific notation? 10 to the 6th power, yes. But this number in front of it is not 1 to 9. It's 2 digits, right? Okay, so it's what? No. So the A means what? 1 to 9 can be 1.1, 1.2, 1.3, all the decimals, as long as all 1.55, right? Between 1 and 10, not a 2 digit. So the number in front of decimal points, you can only have 1 digit, not a 2. 2 we will not call it scientific notation. Okay? So if you look at the power of 10, if you pay attention to power of 10, if we have because for scientific notation it actually is right in this style. So if I have 1.234, this one not on your paper, okay? So if I say times 10 to 1 power, do I have a scientific notation? A number between 1 and 10, right? 1 point something, 9 point something. Okay, up to. And times 10 to the 1 power is what? Times 10. You end up 12.34, right? If I have 1.234 times 2 to the second power, do I have a scientific notation? Yes, but what's this number? You times 100, then you end up 1.3, right? If I have 1.234 times 10 to the third power, do I have scientific notation? Yes, a number from 1 all the way to 9.9999, right? Between that, 1 digit here before for the whole number part with some decimals. So times 1,000, you have 2 and 2, 3, 4. If I have 1.34 times 10 to the 4th power, still scientific notation. But what does this number actually is? Times what? 10,000. So you times 10,000, use your calculator, you should have this. Okay? But in concept, what do you have? Take a look. Times 10 once. So it was decimal here, now it's here, right? That means you move how many places to the right? 1 place, right? Then if you times 100, 10 to the second power, you move how many places? 2 places. If you times 10 to the third power, you move how many places? Become 1, 2, 3, 4. 3 places. If times 10 to the 4th power, how many positions you should move to the right? 4 times. depending on how many powers you do the calculation, you will realize you have to the fourth power, you have to move 4 times. Decimal point would be here. That would be 1, 2, 3, 4, 0. Right? So actual operation is doing that way if you actually multiply out your scientific notation. Okay, that's actual meaning. But if we ask you to write a scientific notation, you have to write it this way, because sometimes that's how calculator represent a number. Okay, so if they can show it to you, they will show it to you, but they only have 9, 10 digit places. If over that, like this one, okay. Second one. Okay, so we have what? 602, 0, 0, 0, 0, 0, 0, 0, 0, 0, so many zeros. 1, 2, 3, 4, 5, 6, 7. Okay, we have this. 1, 2, 3, 4, 5, 6, and 7. Okay, if this big number, then calculator only have like what? 10 9 digit. They cannot show you. If they show you 9 digit, 10 digit, they will lose all those numbers. They cannot do that. So they have to show you with scientific notation. So like this, okay? So how it will show you? It will show you, so you have to sum number 10 to the power. You have to convert regular number back to the scientific notation. But which number you should put in front of the 10th power? We say you can only show 1 digit, right? The remaining has to be the decimal. So would be what? 6.02. That means the decimal point was here. You move up to here. How many places did you move? 1, 2, 3, 4, 5, 6, 7. So that's 21 places. Then plus 2 places. So totally is 23. If you write a 6.02 times 10 to the 23 power, it's the same thing as this number. Is that right? Because just like we say, you multiply 10 to the power, you move the decimal places to the right 23 places. If it's here, 23 places, then you will end up correctly. Okay? So this is scientific notation. So how the calculator will show you? It will show you this way, 6.02. Then you will see the E and 23. So if you see 6.02 E23, it means this guy. Scientific notation. 6.02 times what? 10 to the 23 powers. Then you actually move the decimal point to 23 times, you end up with that number. That's what it means on your calculator. Got it? Okay. Then on your paper, we are on page 5, right? I wrote the 6, that should be what? So I wrote the 5, that should be 2. Then this one should be 3. If your calculator show 2.0541 E6, what are they talking about? E6 means what? Scientific notation, 10 to the power. It means times 10 to the 6th power with original number 2.0541, right? So what's the actual number? So 10 to the 6th power means we move your decimal point how many times to the right? 1, 2, 3, 4, 5, 6. That would be place. Then empty place, you put a 0. right? So your number should be 2054100. Is that right? So that's actual number. Then on your paper, there shouldn't be 6, there should be 4. Another thing you might see is if you see 7.45 e to the negative 9. Sometimes it's a negative there. Negative is opposite of positive, right? So if positive, you move to the right. Negative, what do you think? Where should you move? You should move your decimal point to what? To the left, opposite of the positive, right? So you will move to the left instead of to the right. How many places? 9 places. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be here, right? So empty places, 4, 5, 6, 7, 8. What do you think you would do? You should fill up with 0. So 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros, right? Then including that's 9. Including 7, that's 9 places. 4, 5. So this number will, if the calculator show you 7.45 e to the negative 9, what does it mean? It means this number. Got an idea about scientific notation? How does calculator, do it with more digit? And they will use e. If it's a positive, means you have to move your decimal point to the right, whatever they say. If it's a negative, it means what? You have to move to the left. Got the idea? Okay, so that would be our section 1.1.